Hi everybody. I hope you are doing well. I'm just going to go through the first problem on worksheet 10 to kind of show you what I would expect for solving problems like these. So reading the question, it says, while driving on the tollway, Mr. Gobble gets stuck behind a slow driver going 22 meters per second. He finally gets a spot in the passing lane and hits the gas to speed up to 38 meters per second in 4.3 seconds. Construct a velocity versus time for Mr. Gobble. Label initial and final velocities, the time he accelerates. After finishing parts B and C, label his displacement and acceleration. Awesome. So we know he starts going 22 meters per second. So let's just pick a spot right here. That's going to be 22 meters per second. And he's going to speed up to 38 meters per second. So I'm going to pick that spot to be right here. Label that over here, 38 meters per second. And assuming it's a constant acceleration, the graph's going to look like that. Okay, in terms of time, we know that entire time takes 4.3 seconds. Awesome. So now I've got to answer questions B and C. How far does he travel during the acceleration, and calculate his acceleration. So the first thing you want to do is write out everything you know. So I know his initial velocity is 22 meters per second. His final velocity is 38 meters per second. I know the total time is 4.3 seconds. Make sure that's a point. And they're asking me how far does he travel. So that's going to be the displacement, the delta x. So if I look at my equation sheet right now, the things I don't know so far is I don't know acceleration. And that's about it. So I don't know acceleration and I don't know the delta x, the displacement. I don't have an equation that I can use if I don't know acceleration. So what I'm going to do is I'm going to jump down and solve for that first. So what is his acceleration? Well, if I know the velocity, initial velocity, time, and acceleration, I can use the equation v equals at plus v naught. That came from the equation for a line, right? It's just y equals mx plus b. So let's solve that. I've got 38 is equal to acceleration times 4.3 plus the initial velocity, which is 22. Do some magic math, and I find out that acceleration is equal to a positive 3.72 meters per second squared. You do not need to have the positive on there, but I'm just putting it there to remind myself, 3.72. All right, so now I can use that in part B to solve for the displacement. Now I know all the variables except for displacement, so there are a couple equations I can use. I'm going to use the one that already has displacement by itself, so delta x equals 1/2 at squared plus tv naught. So that's going to equal 1/2 3.72 times 4.3 squared plus 4.3 times 22. Don't forget to square the 4.3 in that equation. That's a common mistake. Add that up in my calculator and I get delta x is equal to 129 meters. Okay, so that's kind of how you're going to work through these. Write out your known things, figure out what you don't know, figure out what equation to use, and then go from there. If I go back to part A for this problem, it said after finishing B and C, label displacement and acceleration. So on this graph, I could say, all right, this whole area down here, that's going to be the displacement, so that's going to be a delta x of 129 meters. So we could have used the graph to find that. And in terms of the acceleration, acceleration is going to be this slope. So the slope of this line is 3.72 meters per second, or meters per second squared. Awesome. Have fun doing the rest. Toodaloo.